Today we're going to talk more about special right triangles, the 30, 60, and so on, and we're going to put it inside what we call a unit circle. So remember that if you have a 30, 60, 90 triangle, right, that has two acute angles, right? In a 30, 60, 90 triangle, you have a small angle that measures 30 degrees, right? And then you have a larger one that measures 60 degrees, okay? Each of these angles is opposite to a leg, right? This is kind of review. The 30 degrees is opposite to the shorter leg, okay? And its measure can be written as 1. Remember, we always do 1 for that short leg. So let's put that here. This is the smaller angle, right? 30 degrees. It's opposite to the shorter leg, and I can write that as 1. The 60 degrees is opposite to the longer leg. Right? And its measure can be written as √3. Remember, so 60 degrees is here, opposite to the longer leg, and I can write that as √3. And then the hypotenuse will measure how much? 2. Good. Okay? So that's how we build a 30, 60, 90 triangle. All right, now, in a 45, 45, 90 triangle, this time we don't have a small and a large angle. We have just two congruent acute angles, and they both measure 45 degrees. And the 45 degrees, the angles are opposite to two congruent legs. So here, if I have 45 degrees, they're opposite to two congruent legs. And their measure can be written as 1. Right? I can just write those as 1. I can make those sides 1. And then how much will the hypotenuse measure? √2. Okay, so that's a review of 45, 45, 90 and 36, 30, 60, 90. But now, this is fine, right? Like the big, the triangle on top, the 30, 60, 90 has a hypotenuse of 2. Okay? Now, suppose we wanted to rescale the triangles, okay? Like on Photoshop, right? Suppose this is like too big. You want to rescale it so that the hypotenuse is 1, right? When you do that, you have to do it proportionally, right? So whatever you do to one side, you have to do the same to the other side, correct? So what I had before is 2, so 1, √3, and 2. Right? Now, if I wanted to make that hypotenuse 2, what should I divide it with? I'm sorry, if I wanted to make the hypotenuse a 1, what do I divide it by? So I want to make the hypotenuse a 1, so I just divide by 2. Okay, so I make it half as big, right? That means I need to also divide all of these other ones by 2 as well. So that means the hypotenuse will be 1. Then I have a 1/2 and a √3/2, right? Okay, the other triangle, I had 1, 1, √2. Now, if I want to make that hypotenuse a 1, I need to divide by √2. But similarly, I need to divide everything else by √2 as well. So now, the new sides of my triangle will be 1/√2, 1/√2, and 1. And here it'll be 1/2, √3/2, and 1. Okay? All right, now there is a purpose why we're doing this. So let's let that simmer there for a while. Let's go to talk about radian measure. Okay, now let's remind ourselves how to go back and forth between degrees and radian. Remember what we said before, that 180 degrees is equal to pi. Right? 180 and pi are the same, yes? So, what does 30 degrees equal to then? Okay, so if you have 30 degrees, right? What's 30 degrees? It's 180 divided by what? So what would you do to 180 to get 3? To get it 30. Divide by 6, right? So to get 30, I take 180 divided by 6, which means since 180 is the same as pi, that would be the same as pi divided by 6. Do you follow that logic? Look at this one. How do you get 60? You take 180 and you divide it by what? 3. That means since 180 and pi are the same, it would be pi divided by 3. So that's how you know, okay, pi over 3 is 60. Pi over 6 is 30. 45, how do you get 45? If you divide 180 by 4, that means that's the same as pi over 4. So this is another way for you to remember that pi over 6 is like 30 degrees. Pi over 3 is like 60 degrees. Okay? All right. Now what we're going to do is we're going to evaluate each of these. Okay? Sine of pi over 6, cosine of pi over 4, and so on. But for these, what we're going to use is the rescaled triangles. Okay, now we have brand new triangles. Those old triangles are dead to us now. Now we have brand new triangles. Here's one of the triangles, 30, 60, 90. The new sides now, okay, the new sides now are going to be 1/2 root 3 over 2 and 1. Okay? And for the 45, 45, 90, the new sides are going to be 1 over root 2, 1 over root 2, and 1. Okay, so these are the new triangles now. You know where we got them, right? We rescaled the other ones. So take a look at pi over 6, right? So tell me, is pi over 6 going to be, which angle is it going to be? 30, 60, or 45? Pi over 6. Which angle is it equivalent to? 30, 60, or 45? 30. 30. So look at the 30. Okay, previously we used to do, whoopsies, SOHCAHTOA. Okay, previously we used to do SOHCAHTOA. And that would have been opposite over hypotenuse. So let's do this for a minute. Look at SOHCAHTOA, right? Sine of pi over 6, sine of this angle. It's got to be opposite over hypotenuse. But now how much is the hypotenuse? 1. So does it make sense for us to divide by 1? You don't even have to, right? So instead of hypotenuse here, we can just drop the h's in all of them, right? I can just drop all the h's. So now sine will just be opposite instead of opposite over hypotenuse. It reduces a whole step. So sine is just the opposite. The opposite of 30 is 1/2. So I just say this is 1/2. Okay? Let's do another one. Cosine of pi over 4. What angle is pi over 4? 45. So, whoops, sorry. So I look at the 45 degrees, right? Now I want cosine. Cosine is now just adjacent. No more hypotenuse. It's just adjacent. Adjacent to the 45, 1 over root 2. I just put 1 over root 2 in one shot. Okay? Now, cosecant of pi over 3. Pi over 3 is what angle? 60. Okay, cosecant of pi over 3. Cosecant is like the sine, correct? Sine is just opposite now, this. But if I want cosecant, I gotta flip it 2 over root 3. Cotangent of pi over 6. That's the 30 degrees. Cotangent is adjacent over opposite, right? So that's going to be root 3 over 2 over 1/2. So this is root 3 over 2 times 2 over 1, which is just root 3. Okay? Now, the biggest deal of all, the unit circle. This is the reason why we've been doing everything. So everything since the beginning of the year has been geared towards the unit circle, right? The unit circle is basically a circle with radius 1. That's where the word unit comes from. It's got a radius of 1 unit. It's like a circle 1 unit long. And it's centered at the origin. The same special angles can be inserted within the unit circle, okay? So what I want us to do here today is we're going to get used to how to navigate the unit circle, okay? And I know, like you've got friends and, everybody talks about, oh, you got to memorize the unit circle. But you know what? I hate it when people memorize the unit circle. So we're not going to memorize anything. We're just going to get used to, navigating it. Okay, so let's get started. All right, so we're going to start with the degrees first. Okay? So this is 0 degrees, right? The first one up is the 30 degrees, then 45, then 60. Okay, now, some of the ones already. So the one up here is how many degrees? 90, right? What about the one here? How many degrees with the highlighted one? 120. The highlighted one. 180. Oops. Okay, what about down here? That's 270. And then if I come back here, that's 360. Okay? All right. So remember how we said this was 30 degrees? Yeah? Okay. The way it works here, from the x-axis, okay, those first lines from the x-axis are always going to be 30 degrees away from the x-axis. So on this side, if this is 180, 30 degrees before that, that's 150. Do you see how that's working out? And then the next one here at the bottom, 30 degrees after the 180 is how much? 210. And then here, 30 degrees before the 360, that's 330. Okay? So that's how you can figure that out. Now let's do the 60s because those are easier. So 60, so that means from the x-axis up, it's 60 degrees. Now here, from the x-axis up, from the 180 up, how much would that be? If you go 60 degrees up from the 180. This one here. 120. Now down here, if you go 60 degrees down, it's 240. Right? And then 60 degrees before the 360, that's 300. Okay? Am I making sense to you all? Okay, so look at the 45 degree here. This one is 45 degrees up from the x-axis. So this one here, 45 degrees up from the 180, that's 135. 45 degrees down from the 180, how much? 225. Okay? And then here, 45 degrees before, that's 335. So if you look at all the red ones, from the 135 down to the 180, that's 45 degrees. From the 180 down to the red one, that's 45 degrees. Yeah.
Instead of, did you mean 315 instead of 330?
Oh, yes, I'm at 315. Sorry. Sorry. That doesn't even make sense. Okay, so that's how we do the degrees. Okay. Now let's talk about radian.
Do you want us to draw out what we did, or do we just need the numbers?
You just need the numbers. You should just, you should just know what goes where. You know what I mean? Okay, let's do the radian. Okay, the radian also has patterns. So let's talk about radian. We're going to put in all of the angles equivalent to the pi over 6. Now remember, pi over 6 was like how many degrees? 30. So these are the ones that are equivalent to the pi over 6. It's basically pi over 6 or 30 up and down from the x-axis. Okay? So here's what you do. So the first one is pi over 6. Okay, this is 1 pi over 6. Now we're going to increase the coefficients. So let's go up, let's go down this row here. You have 1 pi over 6. Then you have 2 pi over 6, right? The next one up. Okay, with 2 pi over 6, you see how the 2 and the 6 can reduce? You throw that away. You don't want that. Next, you have 3 pi over 6. That reduces. You don't want that. 4 pi over 6. The 4 and the 6 will reduce. We don't want that. Next comes 5 pi over 6. Now, for the first time, the 5 pi over 6 does not reduce, so that becomes the next one over. Then moving past, 6 pi over 6 reduces. 7 pi over 6 doesn't reduce. So basically what you want is, you don't want the fraction to reduce, you want the 6 to stay in the bottom. Okay, 7 pi over 6 works. 8 pi over 6 reduces. 9 pi over 6. 10 pi over 6. You can reduce all of them. 11 pi over 6 does not simplify. So that's the next one. And then the next one over, 12 pi over 6. How much is that if you cancel the 12 and the 6? 2 pi, so we made a full circle. So, math people, right? We never memorize what goes where. We always think to ourselves, okay, we have 1 pi over 6, and then 2, 3, 4, 5 pi over 6, 6, 7 pi over 6, 8, 9, 10, 11 pi over 6. So just find the coefficient that doesn't cancel with the denominator. Okay? All right. Next, let's do the pi over 4s. These are all the ones that are the pi over 4s. So here we have 1 pi over 4. Okay? And then 2 pi over 4 cancels. 3 pi over 4 doesn't cancel. 4 pi over 4 cancels. 5 pi over 4 doesn't cancel. 6 cancels. 7 pi over 4 doesn't cancel. So that's the one. So this way, you know exactly where 7 pi over 4 is if I ask you, right? It's like, okay, 1 pi over 4, 2, 3, 4, 5, 6, 7 pi over 4. Okay, that's how we count through them. Okay, so let's do the pi over 3s. Okay, these are the 60-degree angles. So all of these are the pi over 3s. So the first one is pi over 3. Then one coefficient up, 2 pi over 3, that's a good one. 3 pi over 3 cancels, right? 4 pi over 3, that's good because the denominator doesn't go away. 5 pi over 3, the denominator doesn't go away, so all those work. Okay? Yeah. Wait, yeah.
Why wouldn't the 2 pi be right next to the 1 pi? Like, why did you skip it?
Yeah, because it's 1 pi over 3, then 2 pi over 3, right? The next one over. So why wouldn't it be in the first quadrant is what you're asking, right?
Yeah, because it goes.
Because it's the next one over, yeah. But look at what happens when you do that. So 1 is 1 pi over 3. It's like 1/3 of a pi, right? So imagine like 1/3 of a chocolate bar. The other, okay, so this is 1/3 pi. Now then imagine you have 2/3 pi. By the time you get 2/3, how much is 2/3? It's this much. So you're past half of it, right? And since this one over here is half a pi, by the time you go from 1/3 to 2/3, you've passed the half. So you got to go to the other quadrant. Okay? So like this, oh, and that was it. So like this, you can always figure out where each of the ones go. So take a look here without looking back, right? Okay, without looking back, maybe just close your note packets for a minute, right? I'm just going to give you a random angle, and I want us to figure out which quadrant it would be in. Okay, which quadrant it would be in. So quadrant 1, 2, 3, 4. Okay, so suppose I have 5 pi over 4. Which quadrant would that be in? Right? So we start counting. 1 pi over 4. So what do you think? 1 pi over 4? What's the next one? 3 pi over 4, because 2 pi would cancel. Then what's the next one? 5 pi over 4. So 5 pi over 4 would be in which quadrant? Third. Right? Because it would be 1 pi over 4. And then 3 pi over 4. Then 5 pi over 4. So it would be in quadrant 3.
I'm confused how you got that.
So that's what we were doing in the previous 2 pages. Okay, so now let's do another one. Let's do 5 pi over 6 now. Okay, so 5 pi over 6. I start with 1 pi over 6. Okay, so let's look here. Let's try to figure out where 5 pi over 6 is. This is 1 pi over 6. Now find the next coefficient over 6 that doesn't cancel. So 2 pi over 6. Does that work? 3 pi over 6. 4 pi over 6. 4 pi over 6. Does that work? No. 5 pi over 6. Okay, that's the next one, right? So I went from 1 pi over 6 to 5 pi over 6. So that's the second item. It means it's in the second quadrant.
Oh, so it's just things that don't cancel?
It's just things that don't cancel, and then you have to like walk through the motions. Okay? Like you have to walk through all of them. So this is in quadrant number 2. Let me give you another one. Okay, how about 11 pi over 6? Think about that, and then I'll have you guys, we'll do like a little vote. Okay, 11 pi over 6. Let's think about which quadrant that would be in.
Like 11 pi over 6?
Yeah, 11 pi over 6. So let's think about.
Or wait,
Yes.
no.
Okay, who says 1? Who says 2?
Oh, wait, because it can still keep going around.
Well, these are all going to be like these are all going to be within one cycle.
Oh, okay.
Okay, so who says 2? Who says 3? Who says 4? 4, right? Because you have 1 pi over 6, 3 pi over 6, no, 5 pi over 6, 7 pi over 6, 11 pi over 6. Okay? All right. So I think we will stop there today.